We will continue what we were doing and discuss two more examples in this video. The next example of a function that we will be looking at is a function h from 0, 1 to r defined as h of x is equal to x. And we want to find the integral of this function. Let's see what we can say about this function from an intuitive standpoint. So the graph of the function looks like this, where here it is 0 to 1, here also it is 1 here. So the area that we are interested in is this shaded area. And we kind of know that this area should be half the area of the square, which is equal to half of 1, which is half. So we expect that the area of this shaded region should be equal to half. So we should expect half as the integral of this function. We will first observe that for a particular choice of tags, calculating the Riemann sum becomes easy. So let P be an arbitrary partition. So let it be of the form xi minus 1 comma xi, I going from 1 to n. Now we will tag it in the following manner. So we will look at xi minus 1 comma xi and take the tag to be the midpoint of these 2 points. More precisely, it is half into xi plus xi minus 1. So this is the tagged partition that we will take. Here this quantity is equal to Ti. Okay, so for this particular tagged partition, S of h p dot is equal to h of Ti into xi minus xi minus 1 and summation of this I going from 1 to n, which is equal to summation I going from 1 to n of half into xi plus xi minus 1 into xi minus xi minus 1, which is equal to half into summation I going from 1 to n x I square minus xi minus 1 squared. So just as in example 1, this will be equal to half into 1 square minus 0 squared, which is equal to half. So for this particular choice of tags, we observe that the Riemann sum itself becomes half. However, to show that the function is Riemann integrable, you have to take an arbitrary tagged partition of norm less than delta and show that the Riemann sum is close to half. So now we have to show that if we take an arbitrary tag, you will still get something close to half. That's the next step. Let q dot is equal to xi minus 1 comma xi comma qi, I going from 1 to n, be an arbitrary tagged partition. Of 0, 1 with norm of q dot less than delta. Now mod of s h p dot minus s h q dot is equal to summation I going from 1 to n Ti into xi minus xi minus 1 minus summation of qi into xi minus xi minus 1, which is equal to modulus of summation I going from 1 to n of ti minus qi into xi minus xi minus 1, which is less than or equal to, by triangle inequality, summation of I going from 1 to n mod of ti minus qi into mod of xi minus xi minus 1, which is nothing but xi minus xi minus 1. You don't need to take mod because xi is bigger, we know that. Now if both norm of p dot and norm of q dot are less than delta, then modulus of ti minus qi should be less than delta. Why? Because both ti and qi lies between xi minus 1 and xi. So both ti and qi lies somewhere in between. So the distance between them has to be less than the distance between xi and xi minus 1, which is delta. So because of this, we get that this is less than or equal to delta times summation I going from 1 to n of xi minus xi minus 1. But this is just equal to delta. But notice that S of h p dot is nothing but half. So this implies that modulus of S of h q dot minus half is less than or equal to delta. So what is the delta of epsilon that you need to take in this case? The delta of epsilon is equal to epsilon. Now let's look at the final function for now. It's a function g from 0, 1 to r given by g of x is equal to 0 if x is rational and 1 otherwise. We have already seen this function. We had seen this in context of continuity and we saw that this is an extremely discontinuous function, discontinuous at every point. And in some sense you should have perhaps guessed that this function is not integrable, and we will actually prove that this is in fact not integrable. To do this, we will look at two kinds of tagged partition. So the partition itself is quite arbitrary. Both the partitions are arbitrary, but the tags are specially chosen. In fact, in one case, we will choose rational tags, and in the other case, we choose irrational tags. That's what we are going to do. So let P dot be a partition xi minus 1 comma xi with tags ti such that ti belongs to q for all i. Okay, and q dot is equal to yi minus 1 comma yi comma qi, I going from 1 to n, where qi does not belong to q for all I. Here we have used a different notation yi minus 1 comma yi only to stress that the partition need not be exactly same as what is there in P dot. And in addition, we are taking the tags to be irrational numbers. Now let us look at S of f P dot and f Q dot. So S of f P dot is equal to summation I going from 1 to n of f of ti into xi minus xi minus 1, which is equal to 0 as f of ti is 0 for all I. Ti is rational, so f of ti is 0. So because of this, this sum, the Riemann sum, is also equal to 0. On the other hand, if you look at S of f q dot, that is equal to summation I going from 1 to n f of qi into yi minus yi minus 1, which is equal to, see, f of qi is equal to 1 because qi is irrational, so f of qi is equal to 1. So we get this is equal to summation I going from 1 to n yi minus yi minus 1, which is equal to 1 minus 0, and that is equal to 1. Okay, so we get that S of f P dot is equal to 0 and S of f Q dot is equal to 1. And here the norm of P dot and Q dot can be arbitrary. So it does not matter. Irrespective of the norm of the partition P, the tagged partition P dot and Q dot, we get that S of f P dot is equal to 0 and S of f Q dot is equal to 1. So if the function was integrable, there would exist an L such that for every epsilon greater than 0, there exists an delta of epsilon such that mod of S of f r dot, where r dot is a tagged partition, minus L is less than epsilon if norm of r dot is less than delta of epsilon. So now take P dot and Q dot, where P dot and Q dot as before, that is tags in P dot are rational and tags in Q dot are irrational, such that norm of P dot is less than delta of epsilon and norm of Q dot is also less than delta of epsilon. Okay, then 1 is equal to mod of S of f P dot minus S of f Q dot, which is equal to mod of S of f P dot minus L plus L minus S of f Q dot, which is less than or equal to mod of S of f P dot minus L plus mod of L minus S of f Q dot. Now, as norm of P dot and Q dot are both less than delta of epsilon, we know that this quantity is less than or equal to epsilon plus epsilon, which is equal to 2 epsilon. But epsilon here was arbitrary. So this means that 1 is less than or equal to 2 epsilon for every epsilon, which implies that 1 is equal to 0, which is a contradiction. Okay, so we assumed that the function is integrable and reached a contradiction, which means that this function is not integrable.